Well, hey guys, it's Josh here, just checking in with you guys here for today. I know that the Linux cast has said that he's going to be producing this video about Btrfs and setting up Btrfs. This video is technically going to be an expansion of whatever he presents, because what Matt at the Linux cast is going to present is probably on a single disk system. But this here, you can treat as your Btrfs raid guide, because, I'm a big fan of the Btrfs file system, and it's honestly my preferred advanced file system to use on Linux, on my servers and everything. So what I've got here is the documentation pulled up here, and I've got these 5 drives we're going to be working with today. And these 5 drives are actually USB flash drives. Yes, I said that. It's real. I'm serious. They're just standard USB flash drives. But anyways, what we're going to be doing is just referencing these three pages. This here is the official Btrfs documentation. All this is going to be linked in the description down below, by the way. And this is the one that they want you to look at, by the way. This is their Read the Docs website. This is the official Btrfs documentation. This is what they want you to read, because it's updated. This documentation is updated a lot quicker than the old website, because the old website was MediaWiki instance, and wasn't really the easiest thing for them to get maintained, because it was hosted over on kernel.org. So every time they wanted to update it, it required a kernel release, and it also required being approved by like this whole chain of people, and it was a mess. I'm glad that they're moving to something that the Btrfs team can actually maintain for us, because Btrfs has a lot of features and not a whole lot of docs, and that's an unfortunate truth behind this. But anyways, what we're gonna do is like I said, we're doing a Btrfs raid. So let's talk about generating a Btrfs file system first of all. So we're going to need to be root. So I'm just going to sudo su to root, because I don't have the root account unlocked on my desktop computer. We'll just cd into root's home directory. That way we can clear that up. And as you can see, I've got the disks listed out. To list them out, just run lsblk. It's that easy. And what I'm going to do is when I wipe these disks, I actually did put a partition table on them, just a standard GPT partition. But you can run Btrfs multiple ways. First of all, Btrfs doesn't care if it's on a partition or if it's on the disk itself. So what do I mean by that? So let's just create a partition real quick here. So I'm just going to use fdisk for this real quick, because fdisk is a bog standard tool. It's basically included on all of your Unix-like operating systems as part of the GNU core utils. And we're just going to pick on dev SDA here. And if I just hit print, you can see that I've got a disk label type GPT. So what I'm going to do is I'm just going to hit G just to make sure that I have a partition table on there. And then I'm just going to hit new, and then I'm going to hit enter a bunch of times to create a single file system. And if I hit print, you can see that we're going to generate one, and if I write, it's going to create a partition. So I'm just going to hit W for write, enter. And now if I run lsblk again, you'll see I have an SDA1. Alright, so now what we can do is we can mkfs.btrfs/dev/sda1, and that'll create a file system. So if I now run lsblk-f for full, I can see that there's a Btrfs file system type on dev sda1. Now I said just about a minute ago that you don't need a partition for Btrfs. So what I'm going to pick on now is SDB. So I'm just going to make my file system directly on the disk itself. And you can see that it's got that partition table on it, because Btrfs is going to overwrite the partition table because there's no partition. And so what I'm going to do is I'm just going to give it the force flag. Might take a minute, because these aren't all the same USB drive. I'm not going to be afraid to admit it. There might be a USB 2 drive involved in this group here, you never know. It might not be the world's fastest thing. I'm still waiting for it. Okay, there we go. It just finished. That must be a rather slow drive. But yeah, so you can see that we created a file system. You can see that it was created without a label. We get a unified. I actually don't know what UUID actually stands for. Post in the comments if you actually know, because that's actually something that I'm kind of curious what UUID stands for. I could probably figure it out, but engagement challenge, guys. Engagement challenge, because every comment that you leave means that more people show general interest in my comments. So leave a comment for me, please. Also hit that subscribe button. Yeah, I know. I'm plugging right in the middle of the goddamn video, right? Shameless YouTube moment. But anyways, now we got a file system on 2 different disks. One's on a partition, one's on the disk. You can see that I've got 2 different UUIDs. And of course, if you've ever installed like these manual distributions that you have to bootstrap, like Arch Linux, Gen 2, Void Linux, which you kind of can, Kiss Linux, you know that all I have to do is, well, actually, first of all, I think I got things inbound, don't I? So yeah, I have. So what I'm going to do is I'm just going to create a directory real quick and mount, and I'm just going to call this test. So now what I can do is I can just mount /dev sda1, and I just want to mount this in test, and just make sure that this is a good disk that I can write to. So what I'm going to do is is just a good old universal touch, and then hi, and then if I go back and then ls, I can see that I have hi in there, and I'm like, okay, that's cool, it works. So let's just clean up after ourselves, and I know that that's a good disk. That's standard if you're used to working with partitions. So now let's go in and unmount that, and now I want to mount, rather than SDA1, let's just mount SDB, right? And then I'm just going to hit up arrow a couple times here to give it the good old write test. It wrote successfully. How do I know? Because I can read it. Oh, right, I can't remove the directory with the rm command because it's a directory. I'm sorry. I tell you what, we'll just make this window float. We'll just put it like right along here. Right? Okay, so I said this was going to be a raid guide, right? So let's mkfs.btrfs. We're going to give it the -f flag. And then if we just go over here real quick and just scroll down to where it says file system creation. This will be also linked in the description down below. You can see where they're calling it with a couple flags here. You can see that we can create a single file system across 4 different drives with metadata mirrored. Yeah, I'm just going to do 4 drives first because we're going to show RAID 1 and 10 in this example. So I can see that I'm going to make RAID 10 for both data and metadata using the -m and -d flag to set it to RAID 10. So -m RAID 10 and -d RAID 10, and then what we're going to do is /dev sda /dev sdb /dev sdc, and then /dev /sdd. And tell you what, for the fun of it, I'll just also give it a tac big L, and we're just going to call this test. Now, big L is just going to apply a label. Oh, I should probably unmount that, shouldn't I? Okay, so now we just run our big file system creation command. Like I said, some of these drives might be USB 2. It might take a minute for it to write. Maybe I should have just bought like a bulk pack of USB drives. That way they were all the same speed. But it's fine, it'll work. But anyways, you can see here, created our RAID 10 file system. We have a file system size. This is total capacity. Total capacity of all 4 drives in raw storage is 117 gigabytes. And if I just run an lsblk with tac f, you can see that they've all got the same UID, just like you would if you would have like a RAID volume on like a more normal Linux system. And now if I mount, and we'll just mount a single drive here, so dev sda/mnt test. Now why am I only mounting a single drive? Because Btrfs is smart. Technically, I can mount any of these drives, and because they're mapped to this UUID and this label, the Linux kernel, in all of its glory, knows that this is all one RAID volume. So if I just do that, and then if I run lsblk again, you can see that I've got it mounted, and this disk is supposed to only have a file size of 29.9 gigs. So if I just run a df-h, I've got 59 gigs, which is approximately 2 of these drives because they're 32 gig flash drives. Of course, there's some overhead losses too. So I know that I've mounted my RAID volume. And as I shown, it should just work if I just write to this here. So touch/mnt test, and then hi. It wrote. And then we'll just rm that to remove it. Actually, we should probably give it the good old read test, right? Yep. Okay. Now, let's talk about the funner file systems. RAID 5 and 6. Of course, RAID 5 and 6 on Btrfs are still a bit shaky grounds. Basically what it is that at the time that this article was written, and we'll just click this one, basically, okay, so yeah, it links to the official documentation on this. Okay, that's cool. So if you read the official documentation, this is actually linked in the Btrfs main page too, man5 Btrfs. You'll see where it says that that it's still a bit shaky, but you can use RAID 5 and 6 on Btrfs. That said, there are some maintenance tips for it. But if you notice, by the way, I don't have any sync tasks running here. I've got OBS running because, you know, I'm recording, and there's some other stuff. But one benefit of Btrfs, because, you know, it's a smart file system, you don't have to worry about sync times on your RAID. Yep, I said it's true. It's true. You don't need to worry about sync times. But what you do need to worry about is balance. And what I mean by that. So let's just pull up the magic of the BTRFS command. So Btrfs file system. And then I can do file system, let's do stats. And then /mnt test, because that's where my RAID volume is currently mounted. Oh, it's not stats. Oops. So, get some usage details. You can see that because my drives are mixed in size, I've got 256 megabytes written to them, megabytes of data written to them. Tell you what, we'll just take a big file and just drop it right on there. So what we're going to do is I'm just going to pull up the magic of rsync rather than the move command, because, you know, these are USB drives. They might not be the most reliable things in the world. So what I'm going to rsync is out of my home directory. Let's do home Joshua videos. I've got like this raw recording right here of this video, which, you know, it's a big, long, lengthy one. It's pretty good file size. This is like a 7 gig file. Let's just put this over here for now, right? Might take a hot minute for it to complete. But, you know, these are USB drives running in RAID, so they're running twice as fast, right? Over a 5 gigabit USB hub connection. So, plus whatever it takes to run all of my other equipment, because I'm a savage. So, but anyways, you can see that I wrote to it with a nice chunky file. And you can see that it's now got more data allocated to it, of 4 gigs apiece. let's just run a sync command here just to make sure. And basically, when I'm running sync, that's telling the system, hey, pause everything else for now. I want to prioritize finishing up all these write cycles. These are USB drives again, and we want to make sure that the stuff that we're writing to them is actually being written to them before we get a little bit too destructive. But of course, I'm just sitting here patiently waiting for these guys. Okay, that definitely took a while. I had enough time to drink not only 1 but 2 cups of coffees. This is probably why you shouldn't be using USB drives for your RAID storage to begin with. By the way, guys, just putting that disclaimer out. Btrfs is not the world's fastest file system. It's definitely not the world's slowest file system. But the performance of this RAID array is not an example of peak Btrfs optimizations. No, but anyways, you can see that I did finish writing, and by the way, the command to be using this is the command to be looking at what I'm looking at here is Btrfs file system usage. Now, what we can do is Btrfs in all of its wonderful intelligence. We can do Btrfs device stats, and then let's just look at dev SDA, and let's see, get some recordings for all of our things. Yeah, according to Btrfs, our disks are still fine, so they are functioning about as good as you expect a USB flash drive to run. They're still good disks. But anyways, let's talk about what happens if these data numbers or these metadata numbers just fall apart from each other. They're not a perfect mirror. At that point, that's what you need to. Let's man, talking's hard today. But anyways, let's talk about what happens if these devices here they're no longer in sync with each other. One gets a little bit farther ahead than the other, and so on. Well, that's when we get Btrfs balance. This is a pretty cool command. Let's first of all reference our wonderful man page. And what this does is it balances block groups on a Btrfs file system. Block group is basically data. Just think of it that way. It's super terrible, but the explanation of it. But that's what that is. We can run Btrfs balance. That'll go through and everything. But before you run a balance, what you need to run is Btrfs scrub. Now, Btrfs scrub is basically where Btrfs will then go across every single file that's in the path, and it's going to check the metadata against the actual data itself, as well as the checks, and go through the checksum for it, and make sure that file's what that file is supposed to be, right? So we'll just run this on mnt test, and I'm just going to give it that path. Well, actually, tell you what, we should run scrub start, right? We should start our scrub. And you can see where it queued up, scrub started. Now, it's going to automatically do this in the background. And we're going to look at status. You can see it's running. It's working. It might take a minute. But you can see it's scrubbing through at the rate of 207 megabits per second. It's going to take us about a minute to get through this, supposedly. We don't actually know because, heaven forbid, that sync command took a while. But it's going to come through. Working hard. Working beautifully. Error summary so far, we're good. So far, so good. Cool. You can see now it says that's finished and that there were no errors found, which means that our file actually did right like it was supposed to. Or at least as far as Btrfs is aware that it was supposed to be written. Who knows? These are flash drives after all. That's why I ran the sync command before I started dealing with all this, because that would have just thrown the Btrfs scrub everywhere. But anyways, how often should you run the scrubs, and how often should you run the balances? Okay, so that's where a different project comes involved. Okay, and I realize I didn't have this actually opened up, but this is also going to be linked in the description. But this is a set of bash scripts and systemd services for Btrfsmaintenance. Now, it says that's from Kdave, but who is Kdave? I don't really know that well, but you can see that he's working on Btrfs. He's doing Btrfs devil stuff. Oh, if you check the mailing list, you'll find out that Kdave is a Btrfs developer, which means he knows his file system probably better than you and I do. After all, if you're watching this video, it means that you definitely don't know what Btrfs is, and you're kind of curious. But anyways, these scripts basically just automatically run Btrfs maintenance stuff for you. And I highly recommend that if you're going to be putting Btrfs into production, you go through and you read this thing. Because it tells you how often you should be running this stuff here, how often you should be running snapshots, how often you should be running the balances, and figuring out all of the stuff that you need to be figuring out to have like a good running file system. But anyways, what's my general recommendations for like how often you should run the scrub? Scrubs, depending on how often you use the data. If you use the data all the time and you're writing, you're moving, you're destroying, deleting files constantly, you should only have to run the scrub maybe once a week. Well, actually, once a week if you're really, really using it. Think of it more like once a month, or whenever you suspect that there's an issue. That's how often you should run the scrub. Just basically, at least periodically, once a month, every 2 weeks or so. I run it every week. That's just what I do. And you don't have to scrub the mount pointer itself. You can actually just run a scrub on a device. So if I can do it dev SDA, and you can scrub per device too. Because if you get a scrub error, it's actually recommended in this documentation here, where I look at the scrub. It says it used to, but anyways, it says that if you get an error in the scrub, it means that you might have a hardware issue. So you want to start digging through all of your devices, making sure that everything is looking good. But if everything's still reading in Btrfs device stats that there's no issues, you just scrub per device until you find out where the core of your issue is. And yeah, you can actually just do that. Now, how often should you balance? Well, balancing is, at most, you run it once a month. You run a balance after you have to swap a drive in or you add a drive into the array, because you can expand and reduce the size of a Btrfs RAID array. So, actually, let's just do this now. So let's do Btrfs. And then... is it Btrfs add? It's been a minute. Yeah, Btrfs device add. And then I've got /dev/SDE/MNT test. So now I've got that device added. Let's talk about the balances here. You can see that now I've got a completely unallocated device, right? So now that we got the scrub, let's just go up here and then just do Btrfs balance, and then I think I need to run something else along with it. Yeah, just start. Okay. It's been a minute since I've actually called these manually. So let's just start. It's saying, hey, this might take a while. It's going to use some CPU. It's fine because I'm on a modern, fairly powerful system and it's not a very large data set. And it's going to start getting to work without any filters. So it's going to do the whole thing. And you can see it starts balancing out the RAID. It's throwing data everywhere and it's figuring out exactly where it can write to, and it's going to sit there and match up everything to where it's supposed to be. Lighted. This is a RAID 10 array with 5 disks at this point. Figure that one out. Because technically, Btrfs doesn't care how many disks are in your array. You can do RAID 5 and 6 with 3 disks if you really want to. And you can do RAID 10 with as many disks as you want. You can do RAID 10 with a single disk. Do I recommend it? No. But you can. I'll tell you what we'll do in the meantime is we'll cover like something that I actually have in production here. So I'm gonna connect to my server here, and what we're gonna do is just run a df-h. You can see that I've got some mounts here. All of this entire system runs Btrfs. So if I do lsblk tech f, you can see I've got Btrfs in all the appropriate places, including my root drive, and you can see that I've got some labels, I've got my data set. It's probably still working. Yep. It's working on restoring from a backup task because, you know, I just distro hopped on the server because we're recording the Home Lab series after this one. I'm just showing this one here to relatively show you how I got set up. But what we're going to do now is let's check serve. Yep, that's an empty folder. So once again, invoke the magic of root. And what I'm going to do is mount, and I'm going to mount this by label. And I want to mount my data partition because I know that's got a lot of these things. And basically what I'm going to be doing is I'm going to show you guys my subvolumes. And I'm just going to mount that to /serve because that's an empty directory. So let's just ls into /serve. You can see I've got 6 folders in here. These are unique. These are actually Btrfs subvolumes. And how do I know that? Because I can run Btrfs subvolume list, and I just want to look at everything on /serve right now. And you can see that there's some Btrfs magic here. Now, I'm not going to be doing a huge amount of writing to those because, like I said, we're starting from a backup on this server right now. It's doing some work, but you know what we can do is see how I'm mounting this. So if I just cat out my FS tab, you can see I've got all my mounts declared. I prefer to mount things by label rather than UUID because I can remember the label in my head. And you can see I'm calling a lot of options here. Just a lot of them. But, you know, let's talk about some of the features of Btrfs. First of all, Btrfs supports file system level encryption. Or not encryption, but compression. Encryption is coming in the future. But I'm using ZSTD compression because, you know, it's performant and it does work. And you can see I'm just running a level 3 compression because when you call Btrfs compression ZSTD, that is the default value. It works for me. I haven't had a reason to step it up too much. You can see that on a couple more. I'm running a level 6 compression You know, just because, you know, that's the backups. How often do I actually need to be digging into my backups? Not very often. I don't particularly care how performant they are, as long as, you know, they work. And you can see I'm declaring a space cache, which I don't know too much about the space cache. But, you know, when I looked at the subvolumes earlier, you can see that they've got an ID number and a couple other things here. You can see I'm declaring my subvolume ID and the subvolume name to mount that. And generally that's what I'm doing. And basically, it's just a minor tuning to Btrfs, saying that, hey, I just want this thing to work. But this value right here, snapshots. Snapshots are a feature of Btrfs, and you know, if I ever cover Btrfs on a root file system in a video, I'll explain to you guys how I run snapshots. It's a pretty nifty utility. For this, I'm just this system I'm going to be working on like backup video next. That's where I'm going to be making use of Btrfs send and receive to manage backups, which that video will also cover snapshots. But anyways, guys, this is going to take forever. Not going to lie, because USB flash drives. But tell you what, tell me what you think of the video. I think I covered pretty much the basics of what I know about Btrfs. There's a couple more advanced topics. I can really go in depth on this because, you know, Btrfs is one of those file systems I've taken my time to do some reading on it and figuring out a little bit. But, you know, there's still a lot more that I can learn about it. Not gonna lie. But tell you what, I'm just gonna call it quits for now because I've got to edit this video and destroy some more flash drives. I'll see ya.